Welcome back, everyone, and thanks again for coming. What I'd like to do in this lecture and in the next one is to categorize different types of cohort studies in two different dimensions. The first thing I'd like to describe is the difference between what we call an open cohort study and a closed cohort study in epidemiology. So first, let's talk about open cohort studies. Open cohort studies are studies built on populations that might be geographically defined. Think of the city you're living in right now. That population is dynamic. People are moving in and moving out of that city every day. Some people unfortunately pass on, die. Other people are being born. So the population, the census of that city yesterday is not exactly the same people who are living in that city today. That's describing an open cohort. It's a cohort where new subjects are being added during the study, and unfortunately other people are being removed. And the best way to think of an open cohort study is to think of a geographical population for a city. Now, not only is it dynamic in terms of people coming and going, it's also dynamic within individuals. If you're looking at smoking, the person who smokes yesterday might not be the person who's smoking today. He might have, or she might have, decided to stop smoking. So the exposure itself might be dynamic and might be changing over time. When we have these types of data, what we measure are incidence rates. We measure person time being contributed by different people into that population, and we're measuring cases that occur out of that person time. So here's just a picture of an open cohort. Basically, what we have are a bunch of people entering the cohort, being followed over time. The first person enters, lasts for, say, 4 or 5 weeks, and then develops the disease of interest. Another person enters at a different period, lasts maybe 12 or 18 weeks, and does not develop the outcome. So each line is a different person. It begins when the person enters the population. It ends in whether he either develops the disease or that person leaves the population. If this is what your data set looks like, what you would choose as your measure of outcome, your measure of incidence, is an incidence rate. You'd be taking the number of cases that happened during that time of disease, and you'd be dividing by person time, where person time is being contributed by different people in different amounts because of the dynamic nature of this population. That's an open cohort. Now, alternatively, the closed cohort is a cohort that's static in its nature. It's defined by having a common starting point for all individuals and a list of everyone's in the study. So what we'd like to do is enroll a bunch of people at risk for developing some outcome at a starting point, the time the period begins. It's not dynamic, it's static. It's static not only in that the people are not moving in and out of the population, it's that you're starting out with 100 people, for example, at some time being followed for the next 5 years. The exposure in closed cohort studies is also static. We classify people as being exposed or non-exposed. The exposure doesn't change over time. A closed cohort assumes there's no losses to follow-up. And at the end, what we're able to do is for each person, since everyone was followed for the same period of time and there were no losses to follow-up, since the exposure doesn't change, we can classify for each exposed groups how many people got disease out of how many people were initially in the cohort with that exposure. We can measure now cumulative incidence. We can measure the number of cases of disease by the number of people. So if we, unlike the dynamic or open cohort, for a closed cohort, you can measure cumulative incidence. Now, as an alternative, from the same data set, you can still measure incidence rates. We will still have how much person time each individual contributed to our study. We can divide the number of cases of disease by now not the number of people, but the number of person time. So in your data set that we've been using, the Framingham data set, when we looked at the outcome being overall mortality from any cause whatsoever, we had 4,434 people at the 1956 exam. All of them were being followed for 24 years. The outcome was death from any cause. There were no losses to follow-up. If we wanted to know whether smokers in 1956 had different 24-year estimated risks than non-smokers, we could estimate cumulative incidence. We would be using that Framingham data set as a closed cohort. if we defined exposure as it was in 1956. Now, there are other types of studies besides open and closed. We could have a closed cohort study in our minds as we develop it, but if we have losses to follow-up during that period of time, then we no longer can measure cumulative incidence. And I tried to stress that in the lectures we used when we talked about cumulative incidence and incidence rates. We used the Framingham data set not to look at all-cause mortality, but to look at, say, the development of coronary heart disease. There we stress that you could not measure cumulative incidence because of the losses to follow-up. You didn't have complete 20 years follow-up for everybody in that data set for the outcome developing coronary heart disease. In that case, what we were really talking about was another study design. Well, this is what our picture would have to look like for a closed cohort study. Everyone's followed for a fixed period of time, or they develop the disease, all-cause mortality. The bolded lines, these might be your exposed people. The less bolded lines might be the non-exposed people. You can measure cumulative incidence. And here's another display of cumulative incidence data from a closed cohort. On the figure on the left describes individuals being followed for a fixed period of time or developing disease. You can measure cumulative incidence. You can display that data in a 2x2 table. On the other hand, if you had a dynamic population, and this is what your data set looked like, people followed for different periods of time, people developing disease and not developing disease, we cannot measure cumulative incidence in that data. On the right here, we could only measure incidence rates. We could only display our data as number of cases relative to how much person time each of our groups were contributing. Now, what I was mentioning a minute ago was the problem with closed cohort studies is they do no longer allow you to measure cumulative incidence when you have losses to follow-up or losses due to competing risks. And for example, when we use the outcome NECHD in our Framingham data set, we were unable to measure cumulative incidence. We had to measure incidence rates. So cumulative incidence are not useful when you have losses to follow-up. You can't measure them. They also don't take into account whether an outcome occurred early in a period of follow-up or later in a period of follow-up. They just take into account that an event occurred. And the other problem with cumulative incidence data is they can't incorporate any way the fact that individuals might change exposure status over time. Incidence rates do allow this. Well, what I mentioned before was another study design, a study design which started out looking like a closed cohort but had losses to follow-up. That's what we call a fixed cohort. A fixed cohort is essentially a closed cohort with a problem, the problem having potential losses to follow-up. And that's what we were talking about previously when we had the outcome NECHD. In that case, for a fixed cohort, all we can measure are incidence rates. So in your Framingham data set, if you're looking at the outcome, all-cause mortality, you can think of that data as a closed cohort. You can measure cumulative incidence, or you can measure incidence rates. If you're using that same data to look at the outcome development of coronary heart disease using the outcome NECHD, no longer is that study a closed cohort because you have losses to follow up. You can think of it now as a fixed cohort, and you can measure incidence rates. And finally, if you have a different type of cohort, a dynamic cohort, you basically refer to it as an open cohort study, and there you have to measure incidence rates. So the type of cohort study, open versus closed, or open, closed versus fixed, indicate whether you're going to be reporting your outcomes, reporting cumulative incidence, as in closed cohorts, or incidence rates, as in open cohorts, or in fixed cohorts, or as another option for closed cohort studies. So here's an example of a fixed cohort study. If we're looking at NECHD as our outcome, we'd like to be able to follow everybody either until the study ends or they develop coronary heart disease, but it's these people who are losses to follow-up or losses due to competing risks that don't allow us to measure cumulative incidence. We have to measure incidence rates in data sets like this. So that's one type of classification, open versus closed. When we come back, I'll talk about another type of classification of cohort studies, prospective cohort studies versus retrospective cohort studies. See you then.